And now we move on to looking at the formation of the moon. Our earliest recorded works, the works of the Babylonians and the Sumerians, they recorded the moon and understood the moon as the god Nana, who also was called Sin sometimes. And with a lot of moon myths, the idea that the moon was some sort of boat going across the sky, or that the moon god rode a boat, and that is what was visible in the night sky, that is common in many of the myths and legends surrounding the moon. The ancient Egyptians, they personified the moon as Khonsu, a youthful god who wandered the night sky hunting demons with a falcon head and the crescent moon in an orb above their head. Amongst the Greek pantheon of gods, the moon was represented by the goddess Selene, daughter of Thea, and Selene would ride her silver chariot across the sky as we observe the moon doing to this day. Now in Norse mythology, the moon was called Mani and was pursued and hunted by the wolf Hati. At the Ragnarok, the end of days, the sort of apocalyptic end of world scenario, the wolf would catch the moon and consume it. No doubt observed from something like a lunar eclipse. Now, going across the world in the Hindu mythology, Chandra, sometimes called Soma, the beautiful god of the moon, he is connected to the elixir of life, and the waxing and waning of the moon was observed to be similar to the patterns of life and death here on Earth. And of course, Chandra had this elixir that enabled him to be reborn into the next moon phase. Now, over in Chinese mythology, Chang'e was the goddess that went to the moon and then found the jade rabbit on the surface, what is still celebrated with Mid-Autumn Festival to this date. The moon continued to be important in the Abrahamic faiths. In the book of Genesis, God creates two lights, the greater light being the sun to rule the day, and the lesser light, the moon, to rule the night. Of course, we also observe this very interesting fact that the moon is sometimes visible in the day. It's sometimes a misnomer to believe that the moon is only out at night. It's just with the absence of the sun, it makes the moon much more visible. In Islamic tradition, the moon reflects Allah's power and beauty, and many things in Islamic tradition, from flags of several Islamic countries to the lunar calendar, the start of Ramadan, all tied to that first observation of a new moon. With the Age of Enlightenment, scientific ideas about the origin and purpose of the moon started to appear at the end of the 1700s. Pierre-Simon Laplace, alongside other thinkers such as Immanuel Kant, suggested that the sun and the planets, including their moons, were formed in a rotating cloud of gas and dust flattened into a disk. We recognize this now as the nebula hypothesis, but at that time it was given the names such as the condensation hypothesis, or sometimes the co-formation hypothesis, that they would all form within the same solar nebula, and that there was no distinction drawn between the disk that could appear around the Earth as the disk of gas and dust that could appear around the sun. Indeed, we could have moons form around moons and moons form around those moons, according to this science. Fast forward 80 years to 1879, and George Darwin, son of Charles Darwin, suggests the fission hypothesis. This was that the Earth was rotating so fast that a giant globule of the Earth's surface separated into space, leaving a ginormous hole in the Earth, and that hole was thought to be the Pacific Ocean. Now, this does happen and would happen if you, say, for example, got some dough for bread and you put it on a drill bit and spun it really fast. what you would find is the centripetal force pulling it back round in a circle could not be provided by the cohesion of the dough itself. The dough would not be able to supply the force required to keep the outer edges moving in that circle, and so they would break off and continue in a straight line, and it would separate and would splatter out into space. The question is, was the Earth soft enough? Did its gravity not provide the cohesion required to hold the planets together? We now know that Earth's gravity was more than sufficient to hold it together, even if it was rotating faster in the past. 20 more years had Thomas Jefferson Jackson C. put forward the idea that the moon could have been captured from the solar system, and that the moon, starting out forming like a planet somewhere else, could have strayed too close to the infant Earth and have become captured by the Earth's gravity. Now, we do see this out in the solar system. We are now aware that migrations have occurred in the outer solar system. We're also aware that moons of Mars, for example, Phobos and Deimos, are almost certainly captured asteroids from the main asteroid belt. But does this make sense for the moon? Well, there is evidence to suggest that this might not be the correct idea, but for nearly 100 years of the last century, this was the best idea for where the moon came from. What changed everything was the acquisition of those Apollo moon rocks. When those rocks were studied down here on Earth, they looked at the chemicals that could be found inside. Now, we know that for every element in the periodic table, there are possible alternatives of greater or lesser mass for each element that have more or less neutrons than usual. We call these isotopes. Now, anything that is formed together, so for example, a large ingot of iron, you would find that it would have a consistent mix of the iron isotopes throughout. It's all formed from the same ingredients. But iron that has been made perhaps in a different place would have a different mix because the conditions were different to start with. Now, when they looked at the isotopic composition of the moon rocks and the Earth rocks, they found that they had the same mix of isotopes, confirming that they were indeed formed from the same material, and this ruled out the capture hypothesis. They had another look at the geology, and they put forward their very best hypothesis of how the moon could have formed. And so in the 1970s, William Hartmann and Donald Davis, two planetary scientists, put forward this thing, the giant impact hypothesis. They hypothesized an explanation for the moon rocks that we observed, and that was that in the distant past, 4.5 billion years ago, a Mars-sized planet that we are going to call Theia collided into the early Earth, stripping the early Earth of much of its mantle, which was thrown deep out into space, which coalesced and reformed the moon. This explained why the Earth rocks of that period from the mantle and the moon appear to be made of the same things, and why the moon is so poor in iron is because the iron from the Earth's core was not thrown out into space. It stood out as a way of explaining all of the observed characteristics of the present Earth and Moon system, but also tapping into the new information that had come back through Apollo. Their hypothesis, which has now been around for nearly 50 years, hasn't particularly seen much more development, but it has had further evidence contribute to it, which makes us now think of it as the leading idea for where the moon come from. It's been simulated that it's very possible that there are these points of mutual gravitation between the Earth and the Sun called Lagrange points. And at a Lagrange point, you can safely sit a spacecraft and it will sit there being tugged equally by opposing gravitational forces, the Sun and the Moon. Now, with some things, like Jupiter, we find in its Lagrange points, specifically the Lagrange point in front and behind it in its orbit, that this is a place that rocks get stuck, and we call those the Trojan or the Greek asteroids. And now with the Earth, we are hypothesizing that what if another planet formed in our Lagrange point? What if two planets shared Earth's orbit back in the early days of the solar system? It seems from that position that we could have the chaotic wobble induced in one of those planets, maybe as something else shifted in the solar system that caused Theia to shift out of its stable position and oscillate towards the Earth, giving a glancing blow which stripped the early Earth of its outer layers, its mantle, and threw them out into space. What we know of such a collision is that any solid surface that might already have existed on the surface of the Earth would have been reliquefied due to the energy of the impact. Both the Earth and the Moon would have become totally molten in space. Now that means that no rocks could come from before the impact and still survive today. If everything was melted down again, there would be no geology from before this event. And indeed, we have some zircon crystals found in Australia, which are 4.4 billion years old. Now, these are basically from within 100 million years of the time when the Earth's surface last set solid. It may not have been the first time because it could have remelted and then set again, but the last time the Earth's surface was totally molten was no more recent than 4.4 billion years ago. And what we do find, though, is that there is an isotopic memory, that some of the isotopes of tungsten 182, for example, suggest that the pre-impact material is still within the Earth's deep mantle, but that it has probably been melted down and reformed, so that though the individual atoms are from earlier times, that it has melted down and reconfigured and formed new chemicals, and that none of these chemicals predate this melting time. If we look around at the Earth, we find that some of the oldest rocks, the Acasta gneiss complex in Canada at 4.02, Lewisian gneiss in the Outer Hebrides, about 3 gigayears. These rocks are the oldest possible rocks, but what you need to understand is that the Earth's rocks are continually recycled and repurposed and plunged down due to tectonic activity. Having examples of rocks that have survived from so long ago is really, really unusual. These rocks are basically survivors that have, because of their position and because of what's been going on around them, almost survived by chance. Now, they are survivors from the Hadean Eon. Now, the Hadean Eon basically is the time which this zircon crystal comes from. It's classified as the time from the formation of the Earth up until the point where the first rocks appear. Now, this crystal has come from within the Hadean Eon. After this, the first formation of Earth rocks, we classify this era in time as the Archean Eon, and this is where the very first rocks and indeed the first life is detected here on the Earth. Because this is relatively new science, we're still finding pieces of evidence that actually add to our picture of what happened back then. Very recent findings from seismology data from the earthquakes that travel through the Earth have revealed something rather interesting, stuck around the outside of the Earth's outer core. It's called a large, low, shear velocity province, which is basically a region where the rocks have a different density to those around them. And what we believe this to be is, or one hypothesis, is that this could be the actual remnants of Theia, that when that other planet hit us, it coalesced and moved into the Earth's core, and then settled there where it's been basically stuck and processed by the slow movements of the mantle ever since. Of course, most of it has been melted down within the liquid outer core, but some still remains. Now, most of the actual material that formed the Moon perhaps did not come from the impactor Theia, but was perhaps the splash of Earth material from Earth's mantle that got ejected out into space. In the same way that if you chuck in a stone into a pond, water will splash back up, we think that the Moon actually consolidated itself from Earth material. This would explain the similarity in composition between the earliest Earth rocks those neases and anorthosites, with the surface of the moon and the rocks brought back by Apollo. Another piece of evidence that the giant impactor explains is why is the Earth's axis at 23 degrees to the solar system? Why does it have this axial tilt that causes the seasons that we enjoy every single year? Now, originally, all of the planets would have formed with an axis aligned with the axis of the solar system. Everything was rotating the same way in the same plane and with a common axis. It would have required the Earth to absorb the angular momentum of something coming from external to itself for it to have its axis shifted out of true alignment like this. And then hypothesizing what could have done that and looking at the sort of relative speeds, it must have been an object about the size of Mars. And so it fits the bill that a planet struck the Earth, absorbed its angular momentum, and the combination of angular momentum of both systems, the rotating on its axis of both planets, and the impact of its huge linear velocity caused the whole new system to be orientated 23.4 degrees to the rest of the solar system. Every time we have summer and winter, it is a reminder that a giant impact of the Earth almost certainly occurred 4.5 billion years ago. Now, when that happened, the Earth's surface was completely molten. What was thrown out into space was a huge amount of material that coalesced and formed the moon. At about the same time as that zircon crystal started to form, due to the cooling of the Earth's surface, it also started to cool and form the moon as well. Material that was thrown into space that had neither got as far as the new forming moon, and neither had fallen back down to the Earth, got stuck in a giant ring system around the Earth. So when that blue zircon crystal formed, the Earth could have had a ring system just like this, that would have made it look very similar to the planet Saturn, but with a molten planet in the center rather than the gas giant. Now, just as a side thought, this isn't necessarily the only time the Earth has had a ring system. Some quite speculative evidence has suggested that about 466 million years ago, now that's 500 million years, so we're talking much more recently, in the Ordovician period, the time when sharks first evolved in the planet's oceans, that the planet might have also had a ring system at that time. And we know that because we found, if we look, and it's very difficult to do so because all the continents have moved, but if we put all the continents back where we think they were in the Ordovician, we find a line of impact craters across the then equator, suggesting the re-entering of Earth's atmosphere of material stuck up in a ring system that was probably thrown up there in the first place by a giant impact, but not as big as the impact that formed the moon. So in just the same way that a rice pudding might gain a skin on the surface as it starts to cool down, the hot liquid moon started to gain a crusty surface. Now we think, to start with, the first crust that started to form was an anorthosite-rich lunar terrae, the highlands that are still visible on the reverse side of the moon, and in some places on the near side as well. But in those lower lying regions, the basins carved out by giant impacts, they remained molten after the rest of it had set, which would have meant that the moon, for a period in its history, had huge oceans of liquid magma on the surface of the moon that then slowly cooled down and eventually set. We think eventually that the moon lost its heat energy into space, and that as you go down inside the moon, though it gets warmer due to the pressure, the moon is not large enough to have a liquid core anymore, and so the whole object solidified over time. The early moon, when it first formed, was probably spinning on its axis very fast, much faster, with a much smaller time period as its orbit around the planet itself. So from here on the planet, you would have seen the moon physically turning in the sky. But what happened is that as the Earth turned underneath it, and the lumps and bumps and irregularities of the Earth passed underneath, things like large mountain ranges and such like in more dense regions of the Earth's mantle would continually provide the same tug in the same direction as those bits moved underneath. And it had the effect of locking in with irregularities in the surface of the moon until eventually any rotational motion of the moon was basically wiped out by tides. Until what started to happen was the rotational motion of the moon slowly bled away until the same surface of the moon ended up facing the Earth. It became tidally locked. And this is why we always see the same surface of the moon facing towards us. Now, a little while ago, we spoke about the libration of the moon and the fact that the moon rocks ever so slightly backwards and forwards to allow us to peek around the outside edges of the moon a little bit. This is what remains of the moon's independent motion, but you can see that now it never fully makes a full rotation other than at the same period as its orbit around the Earth. It turns on its axis once in 27 days, the same amount of time as it takes to orbit the Earth. One of the things that we have found by placing those laser reflectors on the moon and measuring the distance to the moon is that the moon is slowly, at about 3.8 centimeters per year, drifting away from the Earth. That means if we rewind the clock, the moon actually formed much closer to the Earth than it is right now. If we go back over the ages of the Earth to here, the Cambrian period on the left, and we've got Anomalocaris, this really bizarre predatory squid, the moon would have been much larger in the sky. And then by the time of the dinosaurs, the moon would have drifted further away. And in some future time, the moon will become indistinguishable as a really bright white dot, but so small that its surface features cannot be seen. It is even possible that we might lose the moon altogether. Now, in the same way that an ice skater, when they pull their arms in for conservation of angular momentum, results in their mass being closer to the center of rotation and the rate of rotation increasing, they speed up. If we slowly release our hands and push them outwards and outwards and outwards, it causes a slow down. If we lose the moon entirely, the Earth's axial rotation might get slower and slower and slower, and possibly may even stop, which would be disastrous here on Earth because it would mean that the Earth would end up in one particular place with 6 months of light and 6 months of darkness. Life on Earth as we know it could not survive such extremes. And it leaves one very interesting question, a question connected to my own PhD of about 25 years ago, is why do we see so many mare on the near side of the moon but not on the far side? The far side is just basically not. Now, one of the possibilities is that being the near side of the moon, if tidal locking occurred really early, is that the magma was physically drawn by the gravity of the Earth this way and filled up all of the craters that were on this side of the moon. But there's a problem with this hypothesis in that it's not the presence of the lava oceans, the dark mare regions. It's the fact that there are significantly greater impacts on the near side of the moon than on the far side to carve out these big holes in the first place. A hypothesis that I put forward over 25 years ago was that the greater abundance of large craters from the very early history of the moon, which these craters would have represented, were probably ejecta from impacts on the Earth. That the Earth would have been hit by huge objects in that early history and thrown lots of material into space. If the moon was already tidally locked, then one object hitting the Earth would turn into thousands of objects scattering out into space. There was a much greater probability that the moon on the side facing the Earth would be hit by objects than the far side. And so this is, I believe, and it is my hypothesis, that the reason why we have the mare on the front surface of the moon is because the moon was struck by all of the debris that was thrown up when the Earth was continually bombarded all of those years ago in the Hadean period.